In the last video, we have seen the basics of interrupts, and in the videos before that, we have seen all about timers. So in this, and I have been saying this for a long time, that the timer or the counter unit is independent of what the CPU does. So in this video, we'll be using timer interrupt, and we'll be showing you how the CPU is independent of the timer unit, or how the timer unit can perform independently of the CPU. Now to do that, what we do is we would with the help of timers, we would generate a delay of 100 milliseconds. We would generate a delay of 100 milliseconds, and then we would with that delay we would blink an LED, and this particular LED is on port D, pin 4. So port D4. Okay, so, and while this is happening, what we would do is we would also display numbers on the LCD. So LCD is connected to the other port, which I've been using in last few videos. So what we'll do on LCD, we will increment a counter, a simple counter variable, and keep displaying it. Now with this, I'd be able to show you that the LED would also be blinking, and the LCD would also, the counter on LCD would also be moving. So this would run in the main code, and this would run in the interrupt service routine. Alright, so now, yeah, we have seen this before. So we would be using a timer 1 to generate a delay of 100 milliseconds. And we know that the crystal on the board is 16 megahertz, and we'd be using the 1024 prescaler. Okay, so that would be 16 divided by 1024. So the frequency would be 15.625 kilohertz. So this is 15.625 kilohertz, or the time for each tick is equal to, timer tick is equal to 64 microseconds. Now in order to generate a delay of 100 milliseconds, we need to so how many ticks we need to generate a delay of 64 microseconds? That would be 100 milli divided by 64 micro. So that would approximately be 15,625. So this is exactly for 15,625 ticks. So now we know that we really need timer 1, because timer 0 and timer 2, they will just go from 0 to 255, so we cannot take such large value. Now, and I'll be showing you how the timer 1 overflow works. So actually this time, so 0 to 15,625, spending this amount of time with a prescaler of 1024 will generate a delay of 100 milliseconds. Now but the timer overflows if the counter goes past, the timer unit goes past 65,535. so this is the highest count. So if you want the timer to overflow after 100 milliseconds, we need to subtract this count from the highest value. So that is okay, I made a mistake here. So it is 1562.5. So this is 1562.5. so 100 milli divided by 64 micro is 1562.5. so let us take that as 1562 itself. Okay, so 65,535 minus 1562, so that is, okay, so that is 63,000 973. Okay, so what we do is configure the timer 1 and start it with a value of 63,973, and it would count 1562 counts and it will generate a delay of 100 milliseconds, and with that 100 milliseconds will blink an LED. And before we go ahead and discuss about the interrupts, let's see how we would configure the timer. Now the first thing to configure a timer is to turn it on, and we're turning it on with the help of TCCR1B resistor, and the value of that we had seen in the previous example. So if we need a prescaler of 1024, the value is 0x05, and after we do that we just need to put this value into the TCNT1 resistor. So TCNT1 would be 63,973. Now if we do that, the next thing is to enable the timers. So enable the interrupts. And to enable the interrupts, we know that first we need to enable the global interrupts, and after we do that, we would be using the timer interrupt mask resistor to enable the individual interrupt, and in this case we're using the timer 1 overflow interrupt. So with bit set operators, we can directly write without looking at the resistor. So we'll set the so the resistor is TIMSK, and the flag or the bit that we need to set is TO timer overflow interrupt 1. Okay, so with this we enable the exact interrupt. Now so we'll go ahead and do this and also write an interrupt service routine. I'll just show you that on the studio itself, and we'll blink an LED as well as display some numbers on the LCD. Alright, so I have the basic setup for the studio here. So first thing first, so we need to include the as we have discussed this before, so we need to include the file which handles all the interrupts for AVR. So this is AVR interrupt.h. So this file has all the definitions of what interrupts are and all about that. So when you just include them, what you do is you just build it once. Okay, now what you would observe is, so in the dependencies file you would see a lot of files coming in here, and since this is 80 mega 32, this im32.h will have all the port definitions as well as the definition of interrupts. So I just wanted to show you that, and if you scroll down this page, so you see all the timer interrupts here. So you can use any of these names. So this is timer 1 overflow vector number. So actually this is the actual vector number from the vector table that we had seen. So you could use any of these three names. So this was the older convention where you would call it as signal overflow 1. You usually use this timer 1 overflow vector. Similarly, you have overflow flags for all of these, and these are defined in the im32.h. Now I'll go back to the C file. Okay, we would also be using an LCD in this video, so so to show the count, so let us include the LCD as well. I have already included the files here for the LCD. You can already see here. Alright, so what we next need to do is define a constant for the LED. So as define LED, and on this board we have LED on port D4, so just type it as 4. Alright, so in the main program, let me first configure the LED. Okay, so that would be port D equals to set the direction we need to use DDRD. So DDRD equals 1 shifted LED time. So this sets LED as output. Let us also initialize the LCD which we have. So this LCD is initialized, and now we'll configure the timer and the timer interrupt. So first let us configure the timers. So this would make TCCR1B if it is 0x05, it would turn on the timer. Actually you could do this later. So now we would put the count in the TCCNT register, and so this is TCCNT1. It's TCNT, okay, TCNT1, and this count is 63,973. 63,973. So I'm directly writing a decimal number in this case. Okay, so after you do that, we need to enable the global interrupts first. So this enables the SEI, enables the global interrupts. So this what actually does is, we've seen this before, it sets the I bit in the SREG register. So this enables all the interrupts. I mean, this allows us to enable all the interrupts. Next we'll go ahead and enable the specific timer interrupt, and that is done by the TIMSK register, and we'll set the timer 1 overflow bit. So that is TOIE1. so this is timer overflow interrupt 1. So this enables the timer overflow interrupt. Now what you could do is, you can you can take this global interrupt enable little up here, so that we enable it all the global interrupts first, then we configure the timers and then enable the timer interrupts, and it does not really matter. Okay, so what we do all the while is, we will declare one more variable here. So let's say I'll take a 16-bit variable, and let me call that as count, and initialize it to 0. Okay, and all the while what we do is, so so let's complete the timer here. So what happens is, the timer is configured with this particular value. It will overflow at 65,536 and it would generate an interrupt. So we need to blink an LED in the interrupt service routine. Now let us define the interrupt service routine at the top here, and the way to do that is the keyword ISR followed by the interrupt number. In this case we are using timer 1 overflow interrupt, so I've shown this. Okay, and then we need to write down what needs to happen here. Now we just need to blink an LED, but before you go ahead and do that, okay, so whenever it overflows, it comes here, and then okay, so let's just blink the LED. So port D, so I'll do the XOR operation so that the LED will be in opposite state as to what it was previously. So XOR equals 1 shifted by LED. So this is a smart way to blink an LED. So every time it comes to the interrupt service routine, it would, the bit would toggle, the LED bit would toggle. Okay, so after you do that, we again need to put this particular value in the TCNT register, because the timer is, although it's not turned off, when it overflows it again starts from 0. So we do not want it to start from 0, we want it to start from the first value. So this is basically reconfiguring the timer counter. Alright, now this would be it. So what we have done is, we have configured the timer with a prescaler of 1024. We have loaded the timer with a specified value, and then we have enabled the timer interrupt. So what it does is, when it overflows, it generates a delay of 100 milliseconds, and then we toggle the LED or just blink it. Now this is it. So the CPU itself, it need not do anything. So what it just does is, it configures this thing and LED will blink by itself. I mean, so it is hardly any work for the timer to do. So let us give it some tasks. So as discussed before, so we'll just increment a number and display it on the LCD. So every time we do not need to do it on the fixed position. So I'll take the position as line 0, character 0, and then I would go ahead and display the number in the on the LCD. So I already declared a variable called count. Let us just use that. We'll increment and print the value on the LCD. So this is about it. So what you could say in this is the LCD would be counting and displaying the number simultaneously, and at the same time the LED would be blinking, so you would not feel any difference. So it's kind of both the things are are happening simultaneously. So let me go ahead, compile this code and see if there are any errors. Alright, so I'll go ahead and upload this code and see how it goes. Alright, so let me reset the board first. Okay, so what you could see here is, the LED is blinking right here, and you could also see that the count is running. So this is happening inside the timer routine. Okay, so you're blinking the LED there, and then in the main program you're displaying the numbers on the LCD. So you could see that both the things are happening simultaneously. So you could try some more examples with it, and what I would recommend doing is, in this example we had calculated the delay backwards. What I mean by that is, we put a value in the in the TCNT register, and we waited till it overflowed. Okay, so this is perfect case where you could use the OCR register, output compare register, and in that register what you could do is you can put the value, and then when the compare happens you could use the the appropriate interrupt for that, output compare interrupt. So by that, what you need not calculate it backwards, like you need not subtract the value from 65 536. You could start the timer with 0, and when the compare happens with the value that you need, you can use the interrupt service routine, the appropriate service routine. So thank you for watching. See you next time.